Hey everyone, I'm Daniel Baines. I'm a senior software engineer here at Arm, and today I'm going to be talking to you about enhancing shader performance with Mali Offline Compiler. So let's get started. We're going to look at the typical shader development workflow that you may or may not be familiar with. So this is typically editing a shader on your host machine, building that shader into an application. And for mobile, this is deploying this as an APK, deploying it onto the device, installing the APK, and then running and profiling it. Now this takes a significant amount of time. It can be quite a frustrating workflow when it comes to sort of iterating over multiple shaders. So what if there's a better way? Well, Mali Offline Compiler can come to the rescue here. Now it doesn't produce binaries, but it comes to the rescue in the way that we can provide shader validation, so you still get compiler warnings and errors, and you get static performance analysis, so you can see things such as register use and thread occupancy. You'll get a breakdown of the various performance pipelines, and it will give you some best practice guidance as well. So I think you can see why this would be a much easier way to rapidly iterate on shaders rather than having to build your application every time. So Mali Offline Compiler is a command line tool, and it produces a set of performance reports that are made up of a number of sections. So I'll go into those a little bit now. The first section focuses on resource use. So you can see it lets you know how many registers you're using, and bear in mind your occupancy. So if you're using less of these, your shader can be more multi-threaded, which is great. It also shows you things such as whether your stack's spilling and how well you're using your 16-bit arithmetic. The next section is cycle use, and I alluded to this before. We break it down over pipelines, so you can see arithmetic, load, store, varying, and texture, how much you're using of each of those and what you're bound by. So in this case, you can see that this shader would be texture bound. Moving on to the next section. Bear with me. There we go. You'll see some workload quirks. So this is like a few things that can have various side effects on the performance of your shader. So an example here is if it has side effects, it wouldn't be able to be removed by hidden surface removal, for example. So just a few things to watch out for, some useful information around what the shader's doing. Now we're going to take a quick detour. I'm going to talk about some geometry semantics, and I'll show you how that relates to Mali Offline Compiler in a second. So modern tile-based renderers compute position first. So what this means is you have your input vertices, you do your position shading, you then do your culling, and then you do your varying shading before you get your output primitives. So what this means is if your data is fully interleaved, so you have your position and your non-position data combined, in many cases we'll find that that will actually be culled, and you would have unnecessarily loaded all this extra data in. So if you split these streams, you're potentially saving a lot of bandwidth, and particularly on mobile, bandwidth is like your major bottleneck. So how does this relate to Mali Offline Compiler? Well, essentially, if we detect that this is happening, we can provide some recommendations for how you can split these streams. So we can give you an idea of where you can save a lot of bandwidth here. What devices do we support? So the great thing about Mali Offline Compiler is we can compile it for any ARM Immortalis or ARM Mali GPU. It goes all the way back to the T720, so that's over 10 years of GPUs. So a great idea here is you're now able to estimate performance for devices that you don't physically own. So you can compile your shader for basically all of our GPUs and see how the performance varies across it. So this allows you to target a wide range of devices. The compiler version is actually taken from the latest driver release. So you can also compare across multiple driver versions if you use multiple releases of Mali Offline Compiler. We can compile for all the major APIs. So OpenGL, we compile from ESL source. Vulkan is from GL, SL, and ESL source, or SPIRV binaries. And OpenCL is from OpenCL source or SPIRV binaries. Note for Vulkan, we don't support HLSL, but if you compile it to SPIRV, you can use it, so it's not a massive limitation. Let's have a look at an example. So on the left here, we can see this is as part of a shader for a specular-based part of a light. And we've run it across various generations of ARM GPUs. And you can immediately see there's quite a big spread here. So one of our earlier GPUs, this would take 7.5 cycles, but our latest GPU, it only takes 0.14 cycles. So that's 50 times faster. So you can see this is a great way to find out maybe why your shader is performing worse or better on various devices. There are some limitations with this static analysis. I'll just go through those quickly. So we only support single shaders, so we can't do link time error checking. can't do link time code optimization. We support stateless compilation only. We can't specialize against the Vulkan pipeline state objects. You can't cost specific control flow paths. We also have to make a few assumptions as well. So we assume there is no control flow divergence, and we have to assume a best case texture cost and worst case load store cost. However, saying that, even with these limitations, we find that generally you'll get quite a good idea of the performance of a shader, so it's still like a very useful tool. Automated analysis. So, like many of our tools in our Performance Studio, we've set Molly Offline Compiler up for automated analysis. So you can output JSON reports, and these are machine readable for easy follow-on analysis. So imagine feeding these into your CI pipelines. So best thing to do, right, is compile all your shaders every night across all ARM GPUs, across a selection of driver versions, and then you can feed that back every single night. You can see your regression testing. You've got a wide range of performance. And once again, I'll emphasize, this allows you to test your shaders on devices you don't physically own. You don't have to go out and buy tons of devices. You can just run it offline. We actually find that we know of many large studios that are doing this and making good use of Molly Offline Compiler. So how can you get Molly Offline Compiler? Well, I mentioned it's part of ARM Performance Studio. It's a completely free suite of tools. If you're interested, grab a photo of the QR code on the right there, and you can download and try it today. And the one on the left will give you a bunch of useful mobile game development resources. And if you've got any questions as well, feel free to come and speak to me afterwards. And also directly behind here after the talks, we have some demos. So we're happy to show you this tool as one of our others. Shortly, my colleague Jay is going to be coming up here, and he's going to be showing you Frame Advisor, which is our new GPU profiling tool. So just bear with me while we do a quick changeover, and he'll come out and talk to you about that shortly.